Okay, a lot to talk about today. We had a G4 storm just roll in. I'm going to wait for some people to show up in the comments, make sure everything's good with the live stream, and then we're going to get right into it. So let me get the comments pulled up. This will be a Q&A as well at the end. Just in general, we're just going to discuss the energetics at play right now on our planet because this is kind of unexpected, but we will go through all of it. So let me get the chat going. If you're watching this later, just fast forward through this section here. Okay, I see someone there. Great. So we are going to discuss what's been happening with our planet because we had this crazy amount of magnetic fluctuation that rolled through today and actually started kind of back yesterday. But really, this took me by surprise. It didn't take everyone by surprise. There were some models made for this solar storm that came in, but regardless, I think the properties of the intrinsic magnetic properties of that solar storm were quite a bit stronger than people expected. And that's why we had a G4 storm. You can see the magnetic fluctuations here across the globe. This is the delta, so the change in B. B is magnetic field strength. They use that to represent magnetic field strength. So the change in the magnetic field strength, here is our legend, and we see that these deep reds are 400 nanotesla swings. So very powerful changes to Earth's magnetic field at this moment in time from this exploding filament partial halo coronal mass ejection that launched on the 25th. We'll look at that imagery as well. If you're just jumping in now, we'll do a Q&A later. We're just going to go through everything and just kind of lay it out. We've also seen some big fluctuations in the Schumann resonances, specifically in that northern hemisphere region out of Tomsk. They had nice clean weather, clear weather, and they had this big power burst showing this connection between Earth's geomagnetic activity and these solar storms, these geomagnetic storms, and our background resonant energy fields that we connect to biologically in terms of just our heart rhythms, our brain waves, our cells, our water, bacteria, microorganisms, our consciousness fields. And so quite a significant event. I typically find that with geomagnetic storms, I have enhanced dream activity, and that's exactly what happened. I woke up right at the tail end of all this, and I had some pretty profound dreams that made me make certain decisions. Sometimes it's like a jolt to your system, and so that happened for me. I'm sure it's happened for other people as well. But yeah, big geomagnetic fluctuations across the globe right now. We can look at our polar one too. Turn this one on. This is where those fluctuations are located mostly, okay? It's at the poles. So we do have some fluctuations in the equatorial regions, but not much. It's mainly concentrated in the polar cusp regions. So this is the South Pole. We see Antarctica there. Here is the North Pole, and the now it's just reset. So we see our time up there, UTC time. See big magnetic fluctuations over the North Pole, over Europe, and then over the South Pole that have dissipated and then kind of came back. It's each energy injection from the solar wind is what's really determining this. We're going to go deep into why some solar storms that don't look significant actually have quite strong effects on our Earth. It has to do with their intrinsic magnetic field properties, because you can have something look a certain way on a chronograph, for example, like a halo CME can look a certain way, but that doesn't mean it's going to behave a certain way. What matters is the actual particle density. What matters is the magnetic field strength. The vector characteristics of that magnetic field. Is the strength concentrated in the southward component? We'll go into that because the magnetic field characteristics that we received from the Discover satellite for the L1 Lagrange point. This is our solar wind data, our interplanetary magnetic field data, show a very strong solar storm. And that is one of the main reasons why storms can be stronger than they should have been. They actually were exactly as strong as they should have been because they have the intrinsic characteristics needed to be a strong storm. We'll talk about that. But again, big magnetic fluctuations over the world right now. We can look at our, I see you all in the chat. Thank you. God bless for being here. We'll do a Q&A later. If you want to ask me a question, you have to do @Stefan Burns, so it pops up nicely. And let's stay on track here with what's been happening with our globe and the energies of our planet. Big geomagnetic energy swings right now too. There's also background planetary resonances, a lot of energy building up in terms of different planetary geometries. We just had a quarter moon. Quarter moons are like inflection points. I saw it last night. It was really beautiful. Really beautiful actually. And probably woke up because of that storm. But quarter moons are like inflection points between full moons and new moons and vice versa. Big news morning. Yeah, a lot of stuff's been happening. It's been crazy. So let's look at our HB60 index to get a better sense of what's really been happening in terms of like our more normal measure of looking at this. And we can zoom in here to make this more apparent. But actually, before we zoom in, let's just look at the overall 10-day kind of graphic. We see a lot of green, which means that we had quiet conditions. But we do see a little bit of like a slow ramping up here. And this is because we received pockets of enhanced magnetism from the interplanetary magnetic field. And then after that, it ramped up dramatically. And we see our spike here. Let's zoom in. This is like the past 4 days now. And actually this reset zoom button kind of covers it up. But 7.667, 8.667 for this plasma filament that exploded. It barely showed up on the chronograph, but it had strong magnetic field properties. If we look at the solar wind data, that's what we see. And maybe there was a combination of factors. But 8.667 for this time period that we just came off of, 1400 to 1500 UTC time. The last measurement was a 6.667. So this clocked in at a G4. When I checked it on my phone this morning, someone sent me a snapshot. When I checked it, it said G4 on the NOAA website. Now that's updated though as it happens. Now that's changed. We'll look at the intermagnet data as well, because most of this data and most of these fluctuations are concentrated around the poles. And there's some interesting characteristics. The magnetic field strength went up for the South Pole and for the North Pole. So it's not this typical decrease. We've seen this big increase in the magnetic field strength for the North and South Pole. We'll look at that data with intermagnet later. A lot to go over in this video. We're just going to go through everything. So if you want like the full breakdown, this is the live stream for you. I see you all in the chat. Hello, welcome, blessings, gratitude. Yes, glad you're all here. I hope you're all feeling well. I know these things can be stressful. They stress the autonomic nervous system, geomagnetic storms. They stress your heart. They alter your heart rate variability. They reduce it. This is more so for sensitive people. So if you're extra stressed, or you have a chronic disease, or you're older, like really old, then you're more susceptible to these things. If you're young and healthy, or just healthy in general, whatever, right? You may just be like, oh, I'm just feeling a little agitated, or oh, I just had some crazy dreams, because perhaps it happened while you slept. But this can also be very stressful and harmful for a lot of people if they have a lot of stress, they have a lot of inflammation or disease, or their immune system's already triggered, they have a cold or a flu or COVID or something. So that's important to keep in mind. If we look at our real-time solar wind data, well, first, I just really want to quickly show you this amazing burst of energy that we got in the Schumann resonances out of Tomsk, Russia, which is near that North Magnetic Pole. It's in that polar cusp region. It's right on the outskirts, showing that energy injection. And this lines up perfectly with that geomagnetic storm. So we'll look at that. And if we also look here, our weather out of Tomsk it wasn't thunderstorms. It was actually a hot sunny day. So there's stuff nearby, but there wasn't like any thunderstorm activity directly over Tomsk itself, which is, where is it? I just had it zoomed in, but I had to zoom out for you all to show you. Well, it's right in this region. It's near Omsk, but it's not Omsk. Either way, so really nice power burst here. I have to keep standing off to this side. This really nice power burst here. We'll look at this. We'll look at all the different data. We also see this out of Hungary. If we scroll down, We also see a very similar increase in the vertical electric field. We'll talk about what that means. A lot to go over. What effects does this have on our physical body? It can have a lot. It just changes the overall electromagnetic potentials of your body. And it also interacts with water and microorganisms. There's a lot of information about how like the foundational Schumann resonance at 7 to 8 hertz is interacting with cells to trigger autophagy and apoptosis. And that's when they use pulse electromagnetic field therapy, but also it can trigger the growth of bacteria and the replication of viruses. And then magnetic field swings are in general changing the force and the flux flow through your body. So there's a lot more that we don't know than we do know, but we'll keep it at that for now. Here is our solar wind for the past 3 days. And so we see this nice ramp up in the KP index. This is a measure of geomagnetic activity. They take all these different magnetic field observatories that are measuring the magnetic field using like a proton magnetometer or a cesium magnetometer or a flux gate 3-axis magnetometer. There's a bunch of different ways to do it. I'm not going to get into it, but we have good instrumentation. No one's lying to you about the numbers for the magnetic field because we have these instruments, tens of thousands of them, hundreds of thousands of them all over the globe with different independent groups, okay? This is a measure of the geomagnetic activity, more so at the poles, because they'll have a greater effect. At the equator, as we saw early in the video, we didn't have much of an effect. And if we go back to that, we click here. If we go back to that, see, if we look at our equator, not much magnetic activity across the equator. I mean, yeah, there are some changes there at the peak, right? Going up to maybe like 100, 150 nanotesla, but it's really concentrated at the poles. So you're going to be feeling these magnetic field swings the most if you're up here. So if you, for example, if someone's feeling these energy effects, like, I had some more impactful dreams this last night, this morning, during this storm. I'm in California right now. I'm here. The swings weren't that great. If I was sleeping up in a tent up in like way up in Canada, then I'm sure I would have had like a psychedelic experience or something, right? It would have been way more. But that's the thing. The effects are always going to be greater at the polar cusp regions because that's where the energy is flowing in. So we see these big magnetic fluctuations up in the top of the northern and southern hemisphere, and less so in the kind of mid-latitude and equatorial zone. Doesn't mean there aren't any effects. We have the ring current gets enhanced and that kind of reduces the field strength, but the effects are strongest there. So if you're living further up, or if you're living, I guess, maybe like bottom of New Zealand or at the base of Antarctica, then you're feeling, the tip of South America, but really it's these Northern Europeans that are really feeling it the most. And yeah, but we can all feel it. These are energy fluctuations across the entire globe. Geomagnetic pulsations are created more and more and more. Here is our solar wind again. And so we see this ramp up. Few things to keep in mind are, let's go here. Let's actually zoom in first. We see that in general parameters are normal, but we do start to see these increases in the southward activity. See all this like purple there? That is showing a strong connection to Earth's magnetic field. And so the more of that we have, the more these purple regions, the southward component, the more connection that solar wind has to Earth's magnetic field. So for 3 days now, we've had this kind of ramping up of our connection to the interplanetary magnetic field, which has been pushing the magnetopause a little bit further in each time. Okay, so this is a building effect too. It's not like all of a sudden it came out of nowhere. This has been building, but subtly, until all of a sudden it did click. Now if we go to our 1 day, we can really nicely see our storm here. Let's full screen this for everybody. And I think I can zoom in even more for you too. Yeah, okay. So what we'll see is we already, like even back here, we already have some pretty nice characteristics. We have 13 nanotesla for the, or like, about 12, 13 nanotesla for the total field strength, and like -10 for the southward component. So that black line here, this is the total field strength for the interplanetary magnetic field. And if we want to see what the interplanetary magnetic field looks like, we can just go right here and we can zoom over really quick. and this is our interplanetary magnetic field. It's all this energy that's being broadcast out from the sun, forming these waves and ripples of magnetism. And magnetism carries energy with it because particles flow along magnetic field lines. So it's electromagnetic fields that are, these particles are trapped in there, and we are being hit by these waves as they propagate out from the sun. And sometimes the waves are stronger than other times. So you can have a large coronal mass ejection, but the density can be low and the magnetic field properties can not be that strong. Or you can have this plasma filament, which when I first saw it, I was like, it's a nothing burger. It turned out it had really strong magnetic field properties. Maybe I should have paid more attention, but we're doing the live stream now. This stuff is inherently unpredictable. We can do our best, but we really this is a whole open playing field and no one is omnipotent in this regard. So that's why I think it's really important to stay humble. And I could have done a better job, I guess, being aware of how this could have been a big geomagnetic storm. So this is a learning lesson for me, I think for a lot of people right now. So that's our interplanetary magnetic field. Let's go back now. Let's pause this. Let's go back. And so this is rippling out. And as the strength of the field goes up, it goes deeper into Earth's magnetosphere. So here we see it went all the way up to 30. There, we see our black line 30 and negative 25. And so the other thing to keep in mind is this data here is 1 hour ahead of here. It depends on the velocity of the solar wind. But this is collected at the L1 Lagrange point, so 1% of the distance to the sun. So this gives us about a 1 hour lead time. So that's why there's not a perfect match between this and that. If we look here, solar wind velocity wasn't that high, only about 400. So maybe even like 90 minutes. So this right here actually came in for Earth time around here. But this is all this set to the same time. Hi everyone in the live stream. Appreciate you all too. Glad you're here. Yes, so we're going in depth and we'll do a lot of questions later. So if you have them, please save them. And I hope you're having a great Friday. Happy Friday. So this went to 30, this went to negative 25, the southward component, allowing for a really strong connection to Earth's magnetic field. And if we look at this, it's a long extended duration too. I mean, here it was 20 and negative 15 or so, then negative 18. We actually had a little dropout right there, which you can just kind of interpolate and extrapolate in between, right? But then right there, 30 and negative 25. So this was a powerful magnetic field that interacted with the Earth. And that's why we had this bump up to 7.67. Now, the other thing to keep in mind too with this is that the magnetic field fluctuations are created by the ionosphere. So we have this magnetopause getting pushed closer to the Earth. These particles are coming into the planet, triggering powerful electric currents to form in the ionosphere that then create magnetic fields that add or subtract to Earth's magnetic field as we measure them at the surface. And so that our upper atmosphere, our ionosphere, is what is causing these magnetic field swings as we measure them at the surface. We can also measure them out at space. We'll look at that data. But if the ionosphere is different or that's more conductive, or like now we have all these satellites, right? And some of them are burning up, creating like this conductive metal layer around our planet. We've never had that before. That's going to change the properties of all of this. That's going to, if you have more conductive particles there, all these ultrafine aluminum ions now and things of that nature, if you have this conductive mesh, this dust, it's going to create really strong magnetic fields that can then create stronger geomagnetic storms on Earth. So there's a lot of reasons why we can have a strong geomagnetic storm from a plasma filament that doesn't look like much, but it actually is. Because A, we're geoengineering our planet, and B, what are the magnetic field characteristics and the density characteristics of that solar storm? If you look here, the density is all the way up to like 35. Very high. A lot of them stay in like the 10 range. Sometimes the density goes down. Here, the velocity wasn't high, but the magnetic field strength was very high. And the density also has been continuously increasing, so very dense. And if you have more particles, then you have more interactions, more charge, more total currents, more magnetic field swings. In general, there's obviously a lot of ways this can be different too. I wanted to show, so let's look at this one now. I think it's actually the last one. Well, let's actually see what this exploding filament looked like. I've been meaning to show this. So here we have our sun, and we'll look at this a few times, but we see this plasma filament. It actually, I think it already went. It's going to recycle. This plasma filament's kind of in this area, and it's kind of difficult to see actually. This is the 25th of June. And so just reset. We'll see it here. See this launch? It just kind of goes like this. It's not the best angle, but it's this really broad filament of magnetism that just launched from the sun like this. It's going to reset one more time. We'll look at this. But just give this a very close watch, especially kind of see around there. And then you see it kind of dissipate over there too. Yeah, so that's what triggered this geomagnetic storm, is this exploding plasma filament. We see it better on the chronograph. I'll rewind so we see that part right there, because it happens early. This is the 25th of today. And so here's Venus for reference. Here's our sun. Here's our C3 chronograph. So we get this far view, and we see this CME right there that gets launched early on the 25th from that plasma filament. But if we watch that again, we'll see that it's like an asymmetric halo. So there's a lot of it that goes this way, but there's also some that goes that way, showing that it was Earth directed. And so see, there's a little bit of a shock wave that goes out like this. So that was from the plasma filament. We had a bad angle in terms of our SDO imagery, but our chronograph showed a little bit more of the true story. But you can't really know what the magnetic field characteristics are going to be from a chronograph. It just shows you kind of the view. It can show you a little bit of the density, right? With just like what it actually, like, for example, what that looks like. It can show you a little bit of the density, but it doesn't show you the actual magnetic field. No power or internet. I'm sorry to hear that. Also, Saturn's going retrograde. Yeah, that's a big component. When Saturn goes direct, whether it's going out of retrograde or into retrograde, there seems to be heightened energies on our planet, because Saturn is this planet at the edge of the solar system for traditional astrology. And it was really, it's the boundary between like the quantum fields and our actual reality. It's a great manifester, brings things in, makes things happen. And usually in a more stressful way. So yeah, Saturn going retrograde tomorrow, I don't think is a coincidence at all. Once you study this, you kind of understand it. So I wanted to show this, because now we're going to talk about why you can have a strong G4 storm from that plasma filament in that asymmetric halo CME. Because you could say it doesn't make sense, or you could say that there's the sky is falling. But if you know some of this stuff, there are explanations for it that don't involve the sky falling. Though we are doing a lot of geoengineering, that's undeniable. With all the stuff that we're spraying, all the stuff that we're launching, all this missile launches, and all the anthropogenic emissions that we have, we're geophysically altering our planet to a huge degree, which is influencing all this. But it's also due to what's happening with the sun. We're at solar maximum right now. The sun is just pumping out tons of energy, like a tremendous amount of energy. We'll look at some of the magnetograms and intensity grams, see all the sunspots that we have right now. But you have this solar wind coming in, okay? You have it coming in like this. Here's Earth, and here's its magnetosphere overall. You have its radiation belts there. The magnetotail stretches out. There's a plasma sheet and these flux tubes that are in the magnetotail, and you have these polar cusps. So Earth has a North Pole, a South Pole, and they kind of go out like this, and you have these particles get funneled down the polar cusp like this. And so it depends on with the particle charge which cusp it kind of goes to, because here's an inward field and there it's an outward field. So if you have an electron, electrons will like go here to the southern pole preferentially, and the positive ions, like protons for example, are more funneled toward the northern hemisphere because they have a positive charge. They get attracted to that inward field. Whereas electrons can travel, they get attracted to an outward field, right? It also depends on the polarity. Electrons have a lot less mass than protons and other positive ions. So you have these particles coming in like this, but you also just have like the magnetic field itself. And so here's Earth's magnetic field, and there at the surface, like, well, at the core, it's extremely strong. It's like, I don't even think that we have the numbers, you know, hundreds and hundreds of microtesla, if not like thousands of microtesla. It's very strong, and then it dissipates 99% through the crust, the mantle, and everything, right, until it reaches the surface. Has a strength, let's say, of 50,000 nanotesla. We're going to look at some data out of Uppsala, Sweden. The magnetic field strength there, it's about 51,000 nanotesla. So let's just say it's 50,000 nanotesla at the surface. Well, magnetic fields decay with the inverse square law. So as you go out, it decays very rapidly. So you go to 5.6 Earth radii, where the GO satellite is, and it has a magnetometer. We'll look at that data. It's only like 100 nanotesla, okay? At 5.6 Earth radii out, here's our Earth, you know, just 5.6 out. This is not to scale, by the way. It's not perfectly to scale. 5.6 out, the magnetic field strength for the Earth is only like 100, 150 nanotesla. It ranges from like 75 to 125, okay? So it drops off rapidly, and that continues. So you just go a little further, and all of a sudden now you're at the same strength as the interplanetary magnetic field and as the solar wind. So the thing with magnetic fields is that, yes, this is Earth's magnetic field, right? And then there's the interplanetary magnetic field and the magnetic field of the sun and the magnetic field of my heart. But fundamentally, these are just fields. And yeah, maybe I can claim some ownership over the one that my heart produces, or the Earth can claim some ownership over the one that it produces, but they're one and the same. Like, it's not like the magnetic field of the Earth can't interact with the magnetic field of the sun because they have some inherent difference in them, right? This is purple and sun is orange, and they just cannot connect. Like magnetic field A and magnetic field B, and they're just totally different. They're one and the same. It's just what produced it. Did the Earth produce it? Did the sun produce it? Did my heart make the magnetic field? Did the big Tesla battery magnet thing make the magnetic field? Whatever. What produced it doesn't matter. The fact is, does it exist? Yes, okay. They're all one and the same. So when Earth's magnetic field reaches the same strength as the interplanetary magnetic field, now it's not really a question of, oh, interplanetary magnetic field interacting with Earth magnetic field. It's just, here's the magnetic field strength, and now they're interacting together. And it's kind of this neutral zone. And so when you get a stronger interplanetary magnetic field, when the interplanetary magnetic field produced by the sun, going out with the solar wind, right, carrying the solar wind and also carried by the solar wind, the charged particles are creating that magnetic field, and the magnetic field is also carrying those charged particles with it. It's a superconductor. They get locked together. It's very interesting. The stronger that is, the deeper it goes into Earth's magnetic field. Because if Earth's magnetic field at some point reaches a strength of 5 nanotesla, right? It keeps this fading and fading and fading. At some point out in space, it's 5 nanotesla. Well, the interplanetary magnetic field is normally 5 nanotesla. So that's where they'll connect. But if it goes to 30 nanotesla, like we saw, when Earth's magnetic field is 5 nanotesla, that is just like nothing for the interplanetary magnetic field. That is all now the interplanetary magnetic field's domain, all the way up until it gets to 30, and now they have that conversation at 30 nanotesla and not at 5. So it doesn't matter what Earth's magnetic field is doing at the 5 nanotesla range anymore. What matters now is its strength at 30, what that distance is, and the deeper you go into this, the deeper the reconnection events are, and therefore the more magnetic flux we have. So for example, I want to see this line here. Let's say this line there, this line there is 10 nanotesla, and this one is 20, and this one's 30, just for reference. This isn't exactly accurate. I see your question there, but I'll read it later. This is 10, 20, 30, right? If the interplanetary magnetic field strength is 10, it will connect at this red line. If it's 20, it will connect at that line. If it's 30, it will connect at this one, just Forget the scaling, just for reference, which means that it's connecting much deeper. These field lines, when they connect, when you have a southward component connect to a northward component, they connect and then they peel back and we get these reconnection events. These magnetic field lines go like this and they'll reconnect back at generally the same distance away that they had the original connection. It's not like this will all of a sudden go way back there, right? That's that outer magnetic line. So now you have a reconnection event in the inner plasmasphere, and these cause particles to stream down to the polar cusp regions. And the deeper you go into the Van Allen belts, right, this region of charged particles, the more you gather up and funnel down into the ionosphere, triggering these magnetic fields that cause Earth's magnetic field strength as measured at the surface to temporarily go up or down. They swing. So there's magnetic field fluctuations out here, but what we're measuring with the KP index are the magnetic field fluctuations at the surface, and those are being created by the ionosphere during the geomagnetic storm, and you'll have stronger ionospheric currents when you go deeper into Earth's magnetosphere and take Earth's magnetopause really close to the surface, and you can then access the higher density parts of our radiation belt. So that is really the more important variable at play. So that interplanetary magnetic field is very important. And that G5 storm, a lot of people are saying that G5 storm, it shouldn't have been that strong based on the size of the X-flare. Yeah, the X-flare strength, gives a sense of how much energy the sun's pushing out, but the magnetic field strength was extremely strong for the solar wind. It went all the way up to 70 nanotesla, which means it was going super close into our planet and connecting. Because everything from 70 and lower, like 70 to 5, for Earth's magnetic field strength now is not really important, it's insignificant. It's like a wave going up. And if there's a wall and the wave is higher than the wall doesn't matter anymore. Not really, right? It'll change the dynamics a little bit, but you have to have a wall the same height as the wave for them to now have that conversation. Okay, do you relate the so-called 3 days of darkness to some solar flare? What are your theories? 3 days of darkness, let's stay on topic here. We're talking about space weather right now, not Bible stuff. Thank you. So if we go, let's look at our magnetometer now, our GOES magnetometer. Because here we really see some of these swings. Okay. So here is our magnetometer and our magnetic field strength as measured by the GOES satellites. This is at 5.6 Earth radii. They're geostationary, stationed at 5.6 Earth radii away, okay? And you see here our nanotesla scale. So -100 going up to 300, 0 is there, 100 is there. So it's typically the magnetic field strength is around 75 or so, 100 or so, right? And you see these fluctuations. When it's when the geostationary satellite is on the midnight side, the dark side, the magnetic field strength is a little lower. When it's on the noon side, the daytime side, the magnetic field strength is a little higher. And so we see this storm come in. Look at the increase in the field strength. We had this quick drop there. We had another one there. But if we go to our 6 hour actually, look at how the magnetic field strength has been increasing now at that region. This is with there's two different ones, but in general they're all going up. And now we're seeing values of, for blue there, 164, and for red all the way to 274 nanotesla, which is way different than the normal, which if you go to even just like the 1 day, we see it's kind of generally in this like 100 nanotesla range, 75 nanotesla range, right? So Earth's magnetic field with this storm has dramatically increased in strength, not only as measured in the radiation belts, but also as measured on the ground at certain places like Scott Base, which is near the South Magnetic Pole in Antarctica, also Uppsala, Sweden, which is a good location. They often register big swings because they're kind of in between the two flux lobes for Canada and Siberia, though to the south. I'm still stuck on the GOES disruption on the 25th. and the inconsistencies of the CME data afterwards. I could be completely wrong, but were there any anomalies on or after June 25th? Yeah, I mean, sometimes these data feeds get cut, and sometimes they get cut for kind of unknown reasons. But no, if we look at our 7-day, we see our magnetic field looking fairly normal. Here's that cutout right there. But then we see the return to normal, but here's our geomagnetic storm, right? The magnetic field strength and the radiation belt has been dramatically increasing because the solar wind has been adding to Earth's magnetic field strength at this moment in time. That doesn't always happen. Sometimes this goes way down. But right now it's showing a strengthening. And if we look, and we're going to get back to our Schumann resonances because I want to talk about this, but we're going to wrap that up more later, and we'll talk about kind of like the biologic effects of all this. I know it's important for a lot of you. But I feel like also we need better conceptual understandings of what's at play, because then or else people are going to continuously be confused. And not saying that I'm all knowing or perfect or anything, but I do see some things that if we understand these magnetic dynamics better, then we won't have those questions and we can talk about things that are more important, at least my opinion. So where is it? I wanted to, here it is, Intermagnet. Okay. This is our global network of publicly available magnetic observatories, which is fantastic. And thank you, Wendy. Thank you, Wendy. So, yeah, thank you so much. Blessings to you. Here we have Intermagnet, and we see our magnetic field data for about the past 2.5 days. And so I'll zoom in on this geomagnetic storm right here. But here we see basically everything's flat and normal, right? There was no storm 2 days ago. But then we do see this kind of the start of the storm with this drop and then this increase. And if we look at our scale range here, this is for Uppsala, Sweden. Uppsala, Sweden. You can type in intermagnet.org and you can get this data really easily. You pull it up yourself, look at it any time. You can go back in time if you want. So you can retroactively study things like that May storm that we had. That's a very interesting one to look at. And so this is 51,700 nanotesla up to 52,100 nanotesla. Again, thank you so much, Wendy. You have a question in there. The sun has risen at 5:54 a.m. for 13 days in a row. That's not normal. Well, I mean, around solstice, it's going to be the same time. If you're living way up north, then that's going to be a longer window. Though if you're up north, it's going to be perpetual sun right now. But yeah, I mean, I'm not the one collecting your data and taking your times, but during solstice, it is going to be an extended window where it's going to be rising at the same time for like 3, 4, 5, 6 days. Around that solstice mark. So here we can choose our data. We'll look at Scott base as well. And if we zoom in, let's zoom into this. Actually, I have to go here and do 2. That did not do it. That did it. Okay. And actually, I think I can make this better. No. Okay, I can't. So here's our geomagnetic storm. And so we see our normal data, and then we see this increase going from our normal was about 51,800 going all the way up to 52,100. But you see, again, that big increase in the strength. A lot of storms will be a decrease or it'll be a big oscillation or a pulse. But this one's been a steady increase, and now it's kind of leveled off, gone back to normal. But this was the peak of that storm. So at the peak of that storm, when we had that KP value or the HP value greater than 8, and that KP value, the 3-hour measure at 7.66, we had the magnetic field strength really strong on our planet. A big swing upwards, not only for Uppsala, but also Scott base. Check this out. If we go to Scott base, here, look at the swing that it had too. Our scale rating there is 62,550 going all up to about 62,900, a little bit just below that. And so we see that our normal magnetic field strength is more about 62,600, but then it had this about 200 nanotesla increase from that, actually 300 nanotesla, and now it's kind of going back down because this storm is coming to an end. but we've seen big swings out of the two polar regions. Whereas if we go to, for example, like near where I am, Fresno, we see it's still within normal ranges effectively. Yeah, there's more volatility and no clear diurnal rhythm because of the storm, but in general, the scale range here is normal. So 47,430 to 47,470. So just 40 nanotesla for the range here. And so our equatorial region, our mid-latitude region didn't experience too much magnetic flux, but the polar regions did, and those telluric currents then go and propagate around the globe and cause some big changes. If we look at our DST index, we also see some changes here. So here's our DST index, and we see that we experienced a drop all the way to about -100. This is based on our ring current. There is another radiation belt called the ring current that flows around our planet, and it's one of the reasons why the magnetic field strength is weaker in the equatorial regions, because it creates this counteracting magnetic field due to the movement of these protons. It's proton dominant, and during a geomagnetic storm it gets enhanced with oxygen ions from the ionosphere, and so it gets even stronger, reducing the strength even more. So we see that there is a -100 nanotesla reduction in the magnetic field strength, and now it's shooting back up. But we're really seeing most of this energy being funneled to the poles. Again, if we go back here, oh look, they're still running for us. If we go back here, we really see that nicely. Now it's kind of at the end of the storm, but we see how much of the energy is just really focused in the polar regions. And we're not even capturing the main phase of the storm anymore, because this is continuously updating and rolling forward with the data. But most of that magnetic field swing is concentrated in the polar cusp regions. Talk about the nova expected. Yeah, maybe later. It's not what we're talking about in this video. So let's look now at our Schumann resonances, because this is the more kind of important thing as I see it in regards to like us and what we're feeling and experiencing, our collective energies, how those interact with us and all of us together simultaneously. So we've been getting these power bursts out of Tomsk for not a week, but close to a week now. There's been some kind of like data cutouts, some people speculating on that. Well, a lot of these are actually caused by thunderstorms over the area. You just check the weather, and if there's like high winds or thunderstorms, or even just rain, then that is what it's from. It's from a local enhancement of the vertical electric field. And what we're measuring here is the vertical electric field. So this is our vertical electric field going from the ionosphere to the ground surface, 0 volts, 250,000 volts up in the ionosphere, 50, 100 kilometers up, creates this gradient, 100 volts per meter about. It's like 100, 130 volts per meter. The air is very resistive. But you have the magnetic field, and you have these different fluctuations that live in this vertical electric field gradient. And you have things that affect it, like local weather. So if you have a big thunderstorm where the charges inside are 100 megavolts, so 100 million volts, then you get a super enhanced vertical electric field, and you'll get something like a power burst. But in Tomsk at this time, clear weather. It was a hot, sunny day. So fair weather conditions, basically. And we get, though, this big power burst. So this is from that geomagnetic storm. This is caused from that energy precipitating down into the northern pole cusp, specifically the one near Siberia, because there's a flux lobe in Siberia, causing a local enhancement of the ionosphere and the charge there, showing up as a power burst in the Schumann resonances. Because if the ionosphere increases in charge, right, then that vertical electric field gets enhanced, and it'll show up with these white colors, which is the scale that they use, the color scale, show up stronger than normal as compared to background. So this is 0 hertz up here. This is 40 hertz down there. So we're measuring these frequencies going from 0 hertz to 40 hertz. This is mode 1 of the Schumann resonances, mode 2, mode 3, mode 4. So that's 7.8 hertz, 14 hertz, 20 hertz, 25, 26 hertz or so. 33, 39 is down here. They start to gain the data after 32 hertz. That's why mode 5 shows up so much fainter than the others, because they apply this filter to it. But we see this big increase. We can actually look specifically at our amplitudes going here. So here's our amplitudes, and we see that mode 1, the white line there, represented by that white line, went up to a relative amplitude of 54. The yellow line went up to 36. Red line went to 26, and green line, which is for mode 4, went up to 20. So we see that all the different modes decrease in their relative amplitude. Mode 1 gets the most energy. But this is a phenomenon that there's been some studies on where they've connected solar storms and space weather to disturbances in Schumann resonances, but often what a lot of those studies have concluded is that there isn't much of an effect. But what matters, after having watched this for a long time now, what matters is the location that you're studying. Because again, if you're studying this somewhere in that equatorial or mid-latitude region, you're not going to pick it up. But if you're studying close to the poles, for example, during the storm, you'll get it. And we see that exactly right here. The timing on this is really perfect. It's perfect. If we go here, this started at what? Well, the peak was really at 1900 local time. Then it goes to 15, we can say it starts around like 16 or so, right? Local time. So you do -7 to get UTC, that's 11 a.m. And if we go back to our solar wind, we see that, remember, this is 1 hour delayed, right? This is 1 hour delayed. So 10:33 was our peak, make that 11:33, and there's your peak solar impact occurring. And if we go back here, this peak right there is 1900 local time, subtract 7 to get UTC, that makes it 12 p.m., noontime. So just 30 minutes after that peak solar wind impact, and that's all right in that region. So this is clearly from this geomagnetic storm, which is really nice to see. What we also get during an event like this is you get this frequency drop. So we see the frequency for all these went down. Mode 1 went all the way down to 7.4. Mode 2 dropped down to 12.9. Mode 3 in red dropped to 18.6, and mode 4 dropped to 24. So pretty significant frequency drops going, mode 2 is typically 14 hertz going all the way to 12.9. So now dipping almost into the alpha brainwave range, whereas mode 1 now is dropping into theta range. So that's why you can have an enhancement of your dreams, because you have your normal basal kind of 8 hertz just at the bottom of alpha range, dipping now nicely into theta, which potentiates dreams and things of that nature, REM sleep and REM activity. And then you also now have the other modes all decreasing. So it's this push down into these more subconscious states where more parts of your body and your energy field are connected together. We also see these sort of drops in frequency and increases in power out of Hungary. And this is a really great station that they have. Looks like they got their magnetic field sensor back up too. This one dropped out. But we see this geomagnetic storm roll through right there. Now they may have had, actually they didn't have local weather of note. You can check. They have, this station's so great because they have all the data. So you can just go to the side here and you can look at the meteorological measurements, for example, or their potential gradient. It's actually a good one to look at. We can look at their potential gradient, and we can see that their vertical electric field really underwent some big swings just recently, especially like over here. See all that? That's all the big increases in the vertical electric field as a result of this geomagnetic storm. Very likely, because they had good weather. If we also go here to their meteorological measurements, we scroll down. Well, it looks like they did have a little bit of, what is this, a little bit of rain? Yeah, they did have a little bit of rain recently. When I checked this earlier, they didn't have any. But they did have a little bit of rain coming in. So what we're seeing here Okay, this is interesting. What we're seeing here is a geomagnetic storm. What we're seeing there is a little bit of rain that occurred. And that could have been actually triggered by the new energy flux from that storm, causing rapid precipitation of clouds and rain. That often happens. What you'll see during a geomagnetic storm, what I've often observed, just out actually looking and observing things, which is important to do, is that a storm will come through. I'll see it because I'm up to date on this stuff, and then all of a sudden, like, we really get an enhancement of what the normal weather is going to be, or there's like sometimes kind of out of the blue weather systems that develop, like just a sudden rainstorm if you're in an area that can have that type of activity, like let's say the east coast of the US, all of a sudden kind of come out of nowhere, or Europe. Due to reported yesterday that the Schumann frequency has increased to 8 hertz. Well, the foundational mode is always ranging between like 7.5 to 7.2 to 8.8 hertz. So, I mean, it's always in that range. If we look at our sun, we're about to do the Q&A. Thank you all for being here. Hope you've enjoyed. Yeah, I think a lot of people have been feeling energy. I often get a little bit more energized at this, especially at the tail end, which helps me make these videos. But here is our kind of our solar map right now. And so we see just a lot of flux on the sun. But what's interesting about this is that right now, there's been very little flaring activity. We can actually very quickly go to our, I think I have it up. Here's our X-ray flux. We see that we've had basically, we haven't had any M flares, not even M flares now for 3 days. So we have a bunch of flux on the sun. You can see that really nicely here as well. Here's our magnetogram, bunch of flux on the sun, no activity, no flares. We had that plasma filament that launched, which is what triggered this geomagnetic storm, but no significant flares yet. It could change. Here are the sunspots. We see just a bunch of sunspots. June is going to set probably a sunspot record for solar cycle 25. And we already had like our values go up in May. And there was actually some periods in May where there weren't any sunspots, not too many on the sun, but we've had continuous sunspots on the sun now. So it's been really powerful for this June. Expect a big increase in the sunspot number for June collectively. That'll come out in a couple days. I'll update you with one of my videos on that. But solar cycle 25, we're in maximum, folks. Like the sun's magnetic field is mid-flip right now. It doesn't happen in one day, it takes some time, but right now there is no clear polarity for the magnetic field on the sun. It's just a complete jumbled chaotic mess. And so we see that these sunspot groups here, let's zoom in, are not in the strike zone yet. They're getting close. We have these guys that just passed through, but we still have all this time for this to go through the strike zone and then also through this zone here. Remember that plasma filament that launched from this kind of quadrant of the sun and triggered this G4 storm. So these guys have some time, and my prediction that I made a couple of videos back is that around July 3rd, we have a chance for some activity, because that's when Mars passes over the 21-degree point of Taurus, which is where that geostorm occurred, where there's been a lot of activity. I've been talking about that for anyone that's been subscribed. I hope you do all subscribe. You know, my channel makes a lot more sense when you're watching the videos regularly. I think some people drop in for 3 minutes and then they leave these stupid comments. And if you're not going to watch the full video, you won't get to the point or to the part where I address the thing that you're calling me out for. So, I mean, that's just YouTube and internet and trolls in general. You can't get too mad about it because it's just humans. That's what we do. So, I don't think there's really too much else that I wanted to show. I think that's about it. And well, let's stay on the Schumann slide, and if people have questions, we can kind of direct them more there. But if you have any questions, now's the time to ask, and we'll do a Q&A, and we'll just discuss the energies in general. I may dip into the astrology a little bit, but I just want to make myself available as a resource for everyone here now in the live stream, and to allow some of these questions that get brought up that I typically won't make a full video on to get addressed. So that's the benefit of the Q&A. Now, someone talked about that nova. There's a star that's 400 light years away. I don't remember the name. That does a recurrent nova. And so what happens is it's a red giant and a white dwarf, and the white dwarf accretes mass from the red giant, and it builds up and eventually destabilizes and does this nova. And so a lot of people are talking about this right now because it's been predicted to occur in May of this year, plus or minus a few months on each side. And so now we're at the end of June, and so people are thinking that this nova is going to happen at any time. Now again, is that nova, the recurrent nova, going to happen at exactly the same speed? Well, that requires a pretty stable system because it's accreting this mass. It becomes gravitationally unstable or something like that, and then it explodes out, creating this increase of light. What we do know is that it already happened because this is 400 light years away. It's actually already happened like 5 times, like 4 or 5 times. As far, if we go off of that, we just haven't had the light come to us yet. So it's actually already happened a bunch in terms of actual like reality, but the light is still taking its time to reach us. So when that's going to occur, we don't know, but at some point it should be visible with the naked eye. I'm going to do a video on that at some point, especially when it happens. If it does, it's very cool. Energetically, I think it's very interesting to have this recurrent nova. I mean, it's in our local interstellar cluster too, 400 light years, speaking to, an expansion and explosion of energy, but on a regular rhythm. And especially here, 2024 has been a big year for a lot of reasons. And so I think this occurring in 2024 is also very symbolic too. So remember, if you have questions, do @ Stefan Burns so I see it really nicely. I'm not sure I'm seeing any questions in here. And so if we don't get any questions, I'm going to sign off. Do we live in dark mode plasma? I don't know what that means. Have you made a video primarily on power line harmonic resonance? If not, can you? Didn't know about this until watching the course and seems concerning. Yeah, so let's talk about that, because that was the other thing with my most recent video about why the G5 storm is so strong. We have a lot of different factors at play, and we discussed a lot of that in this video. The strength of the interplanetary magnetic field. How strong is the interplanetary magnetic field? Again, the stronger it is, the deeper it connects in the Earth's magnetic field, and the closer that energy flux occurs, it goes right in. Thank you, Tracy. God bless. Race, quit. Okay, God bless. Thank you so much, Tracy. I really appreciate it. So, when you have a strong interplanetary magnetic field, that affects the strength of a geomagnetic storm. When you have higher density, higher velocity, that affects the strength of the geomagnetic storm. When you have like 7 halo CMEs in a row impacting, and they form these cannibal CMEs that are stronger, that impacts the strength of a geomagnetic storm. That was unprecedented back in May, having like 6 or 7, or we lost count of how many halo CMEs got launched rapid fire. That's crazy. You don't just need one massive X flare. But what's also important is what's happening on the Earth. Again, the swings in the magnetic field strength are based on the changes in the ionosphere. Now, aurora are based on particles precipitating down into the atmosphere, causing the different colors that we see. They air glow, and they have all the greens and the blues and the reds and everything. It's all these different kind of reactions that are occurring in our atmosphere. Well, particles flow along magnetic field lines. So when you have a magnetic field that is stable, right, it's harder for them to flow down because they'll hit the ionosphere and they'll interact with the atmosphere there. The ionosphere is our atmosphere that's collecting all these particles, and the reason it's the ionosphere is because it's charging up from those particles. But if you have funnels in the ionosphere, you have these ducts, for example, in the ionosphere, you can have particles flow through it, and now you have a higher likelihood of having aurora. And typically you have aurora around the poles because these funnels naturally exist. These polar cusps naturally exist that funnel them down into our atmosphere, creating aurora. But as you create magnetic fields on the surface, and you're also creating this more conductive mesh of metal and aluminum particulate from satellites. This is recent geologic time. You have to think in geologic time. 1,000 years ago, there was no satellites. As far as we know, there have never been satellites on our planet, right? We've had meteor impacts and things of this nature. We have micrometeorites that burn up and form this layer, but the amount of material that we're putting out in low Earth orbit is like millions of times more than the natural flux that we get at this moment in time with like micrometeorites. So we're creating that conductive network. We're creating all these magnetic fields from the surface. We have our power lines. If you basically can't walk anywhere and not measure 60 hertz or 50 hertz, depending on where you live, if you have a magnetometer. That's standard knowledge. If you're a geophysicist, you have to filter that out. You could be out in remote wilderness and you'll still measure 50 or 60 hertz depending on where you are. And that's a big problem. And what that creates is these power grids are creating these very strong pulse electromagnetic fields that propagate out across very huge areas. And they also propagate upwards. These frequencies are very low. 50 hertz, 60 hertz are near the Schumann frequencies, and so they don't attenuate easily. And that's why you can measure them way out into the middle of nowhere. And so they also go up. And what we see in our magnetic field, so we have our magnetic field. I see a lot of questions rolling in, but I got to keep with this one. We see our magnetic field goes like this. These pulsed waves travel and pulse along, vibrate along those magnetic field lines, and they have resonance with particles. It's called ion cyclotron resonance. A particle will resonate with a frequency wave depending on the magnetic field strength, depending on the particle properties, like its charge, its mass, and dependent on the frequency of the wave it's resonating with. And so when you have ion cyclotron resonance, you can pull these particles and destabilize them and cause them to flow down the field lines. And so 50 and 60 hertz is right in that ion cyclotron resonance band. You can read the original research paper going back in 1950 and everything that's been done since. And then it becomes pretty clear. But normally on our planet, it's the Schumann resonances and the energy from lightning strikes that causes energy precipitation. But with power grids, we have these on continuously 24/7, and it gets enhanced during the summer because everyone's turning on their AC. You know, we increase our power grid consumption and we ramp it all up during the summer in the Northern Hemisphere. Thank you, William. God bless. Will there be aurora tomorrow? It would have already happened. Though there, perhaps, but no, it would have been last night. So you have this particle precipitation. So what we have is we already have the magnetic field slicing through all parts of the ionosphere, right? Earth's magnetic field is just going everywhere. It's everywhere, right? It's everywhere. But if you have power line harmonic resonance, what happens is it's pulling these particles down in areas where the flux is the greatest. This vibratory flux is the greatest. And if there's enough being pulled down, it will clear out a channel and create a magnetic duct. And now if you have a geomagnetic storm flowing through an established duct, now you have a lot of particles skip the ionosphere and go directly into the lower atmosphere, causing aurora. And we see that most of our power systems, they're not in the high northern latitudes for the North or South Pole. Most people live in the mid latitudes, or a lot of people live in the equatorial regions. And we've been increasing our power grids, not only 50, 60 hertz, but we've also been radically increasing our cellular networks. And so, for example, 5G is at a frequency. Now, when you get to the gigahertz range, you start to interact with water much more so than when you're in the sub-gigahertz range. This is based on the magnetic susceptibility of water. It's why a microwave works. And when you start to go from 1 to 100 gigahertz, the water will actually absorb that energy directly. And so all of our 5G cell networks are effectively pumping out radiation, microwave radiation in that gigahertz range that is being absorbed by water, causing it to be more energetic. That also explains in part why we're seeing more volatile weather patterns and systems, because we're just creating a mass amount of charge in our hydrosphere as compared to just 3-4 years ago. We did not have 5G networks widespread 3-4 years ago. Now we do. and they're on 24/7. You know, these things don't run on zero energy. They are hooked up to the power grid and they consume a massive amount of energy. And it basically goes up, gets propagated into an electromagnetic wave, which then gets absorbed into the atmosphere. Energy is not created nor destroyed. Where's that energy going? It's going into our atmosphere. Add on top of that all the CO2 gases, all the methane emissions. Add on top of that like ozone destruction and volatile gases and all this stuff that we're pumping out just collectively, right? And you get an extremely unstable atmosphere. Our oceans are also destabilizing. They're more stable because water has a stability characteristic to it, but the temperatures are going up, the acidity is going up, right? We have these mass chloral bleaching events. They've already absorbed so much of the CO2 that we've released, but you have these magnetic ducts that form as a result of electromagnetic fields that we create, like power lines and like cell towers. And that allows for the particles to funnel down and be seen in more regions than they would have otherwise. Additionally, compared to the past, we have more people now with cell phones and taking photos and everything. And we have more people even aware of this. We have the internet. So like back with the Carrington event, there was probably a lot more reports, you know, tribal people in Africa and everyone from around the world, you know, saw this stuff. It's not like everyone wrote it down like, "Dear diary, you know, today on the ship's log." Like not everyone did that. Now everyone and their grandma can go out with a phone and like get this stuff. And you can set the exposure to low. So you can get a photo of aurora even though your exposure is at 15 seconds. And so it's much easier to observe this stuff now too. And so that is also influencing the fact of, oh my God, there's more aurora. Well, yeah, we have these magnetic ducts. We have everything I just laid out, but we also just have more people paying attention to this. And we have more data coming in, biasing the effect, making it seem like it was more significant than it was. And it was significant. The G5 storm was significant. This storm that we just got through was significant. But those are all the factors at play. It's important that we keep all that in mind and not just go straight to a fast conclusion, oh my God, the world's going to end, right? The magnetic field's going to flip. It could. I don't think it's likely. We don't see the dipole strength of Earth's magnetic field decreasing to the level needed. I talked about this in my last video, decreasing to the level needed for an excursionary reversal. And like we saw with the storm, the field strength actually went up. So there were some questions that rolled through. I'm going to scroll up to get them again. Sorry that I missed them earlier. What will happen if the sun's poles flip? This is a normal occurrence that occurs all the time. The solar cycle every 11 years, it's going to flip and then we'll be in solar minimum and the energies should decrease on our planet for a few years. Hopefully long enough for us to realize not to be doing some of this dumb stuff that we do, but we'll see. The new radiation belt from May's geostorms reflects data points that predict strong earthquakes in Northern California and Oregon. Does this geostorm strengthen that possibility? Well, it depends on how long-lived that radiation belt is, and it seems to have faded out. So I wouldn't be surprised if we do get that strong earthquake in those regions because of that storm. It was quite significant, and it takes time for these things to occur, but based on the data, I'm not seeing that radiation belt there anymore. It wasn't as long-lived as maybe it would have been necessary for an earthquake to occur. If you're wondering what we're talking about, I made a video talking about the Great Geomagnetic Storm and enhanced probability of earthquakes in certain areas. It's a good one if you want to learn this stuff. Can sudden space weather events like this one cause a massive blackout systems out of the blue, or is this something that we can see coming? So we have a little bit of a lead time based on solar observations, the chronograph. Okay, we have something coming towards us. We have that 1 hour lead time on average with the Discover satellite, but the strength of it is kind of an unknown. So again, this one was quite strong, the interplanetary magnetic field. We don't know how strong the telluric currents of the ionosphere can be, because that's what causes a power grid failure with a geomagnetic storm. Is you have these currents in the ionosphere, the upper Earth, right? And they're flowing and they induce telluric currents in anything that's a conductor down below. So they induce telluric currents, for example, in power lines and also like underground cables, and that can then overload systems causing a power grid collapse. So now we have a better ability to handle these geomagnetically induced currents, GICs, but if you have a really strong storm and it hits certain areas and maybe it's at a critical threshold, then yeah, you can get a power outage. But I think the risk of a power grid collapse is still there, absolutely, but it's not as high as maybe a lot of people make it out to be, especially those that capitalize on making you fearful and afraid. Now, during a geomagnetic storm, we get these geomagnetically induced currents. We also get them in our body. Our body is full of biologic currents. I mean, water, we talked about how water absorbs electromagnetic fields. Every water molecule is a magnet. We're 99% water molecules. They hydrate in between our DNA, proteins, everything. They're absorbing these energies like the Schumann resonances. And we have all these different circuits, for example, in our fascia, in our collagen, in our bones. Bones are very bioelectric. It's very interesting. You should read the book, The Body Electric by Becker, Robert Becker. That's a fascinating read. It's really the best way to learn about bioelectricity, to go from like 0 all the way up to, you know, a pretty good level, because he lays it out very nicely. He's a very good educator. But these sort of events also charge us biologically. They can increase our metabolism. Our metabolism is just what are the reactions happening in our body. So if you have more reactions, more energy, more ATP, you have a greater metabolism. Some people have lower metabolism, some people have higher metabolism. Something like this will increase your metabolism. Metabolism will in general cause more randomness in activity. And so you have a higher chance of like free radical activity. And so if you are already inflamed, for example, you're already in pain, you already have some sort of condition, pain is just a signal. Pain is saying, hey, there's something wrong, right? So what's wrong? Is it inflammation, right? Is it a lot of free radicals in your joints, for example? Then a metabolism increase or something like this can then make that worse. A lot of circuits of the brain, right? We have brain waves. How do you think those are created? Those are created by circuits producing these pulsed fields, because you need an electric current to create a magnetic field. So if there's no more questions, we're going to sign off. We'll take just a couple more questions if they pop up quick. Just do @Stefan Burns. I hope you've all enjoyed the live stream. I wanted to jump on as quick as I could once I saw this. I know this is a pretty energetic event for a lot of us. Lots been happening. How about that debate? I knew it was going to be a dumpster fire. I didn't even watch it. I watched like 2 minutes. It was awful. But yeah, that's everything that's been happening. So if there's no other questions, then I just wish you all well, and I'll keep you up to date on things. But yeah, again, this is kind of a masterclass. The fear factor. Yeah, it's really important. I mean, everyone has motives, right? And some motives are not pure. Like, what are my motives? My motives are to better understand the world and to improve like community and our energy systems, and to build out a more resonant spiritual world and like community for all of us. Some people want to capitalize on your energy and your fear, and they're a vampire and they feed off of that because they don't have the internal generating mechanism themselves. They don't have that solar fire within them. They can't do it. They are hollow and dead inside, like a black hole, all right? This is just the universe. There's black holes and then there's stars. Some people are stars, some people got the Leo, some people got the sun, some people need to drain, suck, and just pull energy from others all the time. And so I think people with my channel see how my broadcasts lift and liven them up. Maybe not for everyone, but I think a lot of people subscribe and resonate with me because I actually boost their energy up, and I get boosted from you guys too, but not in this vampire cultish like fear narcissist way. So yeah, it's kind of off topic for my channel, but it's really not, because this is just like humanity and social interactions and energy and spirituality, everything combined. That's what this channel is. This channel is just my exploration in life. And so it does connect into all this. And it's important to look and see people's motives and assess them as accurately as possible, and to really look at actions more than words. You can say a lot of stuff, but what are you doing? What are you actually doing? like when something like this happens, I jump on live stream right away. And like I went to the Schumann Resonance Observatory in Hungary, so I could actually learn about this stuff directly, see the ball antenna, right? I actually went to school for geology and actually worked as a geophysicist, right? Like it's just actions over words. It's very important. So I'm working my way towards getting some of these things set up for like the Schumann observatories in the US. Right now it's just words. Soon there will be results, but those are my intentions. If those weren't made clear to anyone before, my intentions are for us to have a more harmonious, peaceful community and existence together globally, and for us to have a better understanding of how we are interacting with the earth, the sun, the cosmos together, so we can build that more peaceful harmony group together. Because once you know something, the truth of something, it's really hard to go back to something that's not your highest good, or a past behavior, or something that's more destructive. That's it is. Once the truth really hits me, then it's a complete software update. I'm like, I just can't do that anymore. I'm a new person. The truth is liberating. Sometimes it can be difficult, but the truth just, it takes you to a higher level of being. And so people that don't want you resonating and vibrating at your highest, they don't want you empowered and liberated and free, they won't feed you the truth ever. Or if they do, they'll give you the little ones that everyone knows, and then they'll feed you a whole bunch of lies. And so that's one of the big problems right now with just the society in general, is that we are tolerant of people who are liars and narcissists, and they have no moral compass, and they will do anything to feed their black hole. And eventually it collapses. So a little bit off topic, but yeah. So let's do just a couple ohms. People liked on the last one. And let's just do an equalization in ohm, and then we'll sign off with that. I'm getting some chills as I say that. This is a good idea. So you can join if you want. You can just do some deep breathing, but let's do an energy equalization, just some ohms. So I can't, I've been talking a lot. I can't promise my ohm is going to be amazing, but just some deep breaths first. The light in me sees and honors the light in you. Namaste, God bless, love you all. I'm glad that you're here. I'm glad that you're part of the channel. I'm glad that you've allowed me to change my life path into the direction it is now, because I've always enjoyed what I've done, but now I really feel aligned. And that's due to all the support and love that I'm constantly being shown. Everyone that gave me a super thanks, I mean, God bless. Everyone that's just here in general, God bless. We are stronger together, and we just have to be the light, the energy, the go, the vroom. So I hope I help you with that, and you help me with that too. So God bless. We'll see you all in the next video. And if you haven't subscribed yet, please do. It really makes this whole journey so much better for everyone. So